Let's find the domain of our 6 trigonometric functions. Remember that domain are the x values that are allowed. Okay, so let's say we have y equals sine of x. If I want to find the domain, I'm looking for the inputs of sine that are allowed. In other words, is there any place where the sine is not defined? So if we look back at our unit circle, the sine is the y-coordinate, and as you go around and around that circle, all the y-coordinates are going to be defined. So there's no problem with the sine function, so the domain is going to be all reals. Same idea with cosine. That's going to be the x-coordinate. As you can see, as we go around and around the circle, there's nothing that's going to make that undefined. So domain is still all reals. Okay, now to find the tangent, we have to divide the y-coordinate by the x-coordinate. So in other words, we have sine of x over cosine of x. So cosine of x cannot be 0. So looking at the unit circle, I'm going to go to the place or places where the cosine is 0 and eliminate those values. So looking for where the x-coordinate is 0, we're at the top of the circle and at the bottom of the circle. So at pi over 2 and at 3 pi over 2, cosine would be 0, which means that tangent of x would be undefined. So x cannot be pi over 2 or 3 pi over 2. But if you think about it, that's just in one revolution of the circle. We can keep going around and around and around, so we could end up at 5 pi over 2, 7 pi over 2, or we could go backwards. We could go negative pi over 2, negative 3 pi over 2, etc., so on and so on. So if you look at the top, the numerator, those were always odd numbers. They could have been negative as well. So the way that we can represent this, as far as the domain is all the reals except any odd multiple of pi over 2. So all reals except, let's say, k pi over 2, where k is just any integer. Okay, so no odd multiples of pi over 2. Okay, same idea with cotangent. Cotangent is cosine over sine. So this time we're looking for where sine is 0. In other words, where the y-coordinate is 0. So that's going to be the right side of the circle and the left side of the circle. So 0, pi, 2 pi, 3 pi, 4 pi, any multiple of pi. So all reals except k just pi, where k is an integer. Okay, so any multiple of pi. Okay, let's look at the secant function. So secant of x. This is defined as 1 over the cosine of x. So again, where cosine is 0 is similar to the tangent function. So we can't have cosine being 0, so secant and tangent will have the same domain. Okay, so all reals except where cosine is 0, and that was at all the multiples of pi over 2, odd multiples of pi over 2. Okay, and last one, cosecant of x is 1 over sine of x. Again, bottom cannot be 0, so I'm looking for where sine is 0, so that's similar to the cotangent, and that's at all the pi's. Okay, so all reals except any multiple of pi.